Hey everybody, it's Dan with yet again another Git tutorial video. Sorry, it's been a while since I've had one, but today we're going to talk about Git Rebase, and I've mentioned the interactive Rebase in a video about squashing commits. This one I want to talk about Rebase proper, the non-interactive mode, and sort of go over what's actually happening under the hood. So I've created here, let's see, a fake repo that I call History Emulator, and those of you that may have some Python experience may be able to read this tiny little amount of code and realize that it's a small script that is intended to create commits for me, and this is just a utility so that I can create commits quickly and emulate the history of an actual project. I just want to show you the git function, so of course it's just committing nonsense to a file, not actual code, but just for the ability to show you these things, I've created this script. So as an example, if I look at git log now, I have 2 commits and I am on the master branch, and if I want to say create 4 commits on the master branch, I just give it the argument of 4, and you can see that 4 commits were created. Now in this video I'm actually going to use a git alias that I call GT, and if you want to use that yourself, it's basically just a bunch of switches to git log so that I can see it in a graph view. So when I do that, you'll notice that I have a linear history here. We just created these 4 commits by running that script on the master branch. So before I get into an actual example here, I want to quickly go over the man page, which I'm sure you're all very excited about. And it is very difficult to read, especially if you're a Git newbie, but I just want to show you the very first example, which I think is incredibly helpful. And it's all ASCII art here. So it says, assume the following history exists and the current branch is topic. So your history looks like this in the example, where the tip of the master branch is a commit called G, the tip of the topic branch is a commit labeled C. And when we get Rebase, what we're actually doing is replaying work from one state in history onto another state in history. And so they show you in this example, if you were to, remember, be on the topic branch, so you're on the topic branch, you say I want to get Rebase with the master branch, the result would look like this. You'll notice early history on master D and E, F and G are not affected, but the topic branch is replayed on top of the tip of master when it used to branch off from E here. And so they're labeled A prime, B prime, C prime on purpose because they're actually different commits. They have a different SHA-1, and the reason for that is they have different parents, and as you may know, the SHA-1 for a commit has the parent baked into it, if you will. So the one thing that I want to point out here, and I'm a very visual learner, so it took me a long time to understand what Rebase was doing until I was able to look at this graphic here, and sort of use a plant analogy. So if you imagine this is like a plant laying sideways and this is a branch coming off the plant, when you rebase, imagine clipping a part of the branch with your scissors, and in the magic world where you can just paste that branch onto another part of the plant and have it grow, that is basically what you're doing. So if you think of that as an analogy, it kind of helps you visualize what's going on. And it can be very confusing, especially when you have a whole lot of branches and they're all rebasing with each other. So keep this graphic in mind. If you feel like you're overwhelmed when you're rebasing, go back and look at this man page. It's helped me in the past. So I just want to point out real quick before we go into the example, I mentioned this, I want to mention it again. The commits themselves are defined by parents. So when we rebase changes, like we do right here visually, and we're about to do an example of that, we actually rewrite the history of these commits, right? So one thing to think about when you rebase is, hey, let's say I branched off a topic branch. I'm doing some work on my A commit. I've guaranteed that I've done some testing and I know it works with some amount of sufficiency. And let's say the same for the B and the C commit. Say you have a project where you care if your code builds and runs. We'll call that the test as an example. When you reapply these commits after a rebase, the assurance that you have to get back to this A state and know that it worked because you verified it earlier no longer technically exists. And I might get into the details of that in another video, but really what I'm just trying to point out here is that these commits are brand new commits, and if you tested on this commit, you technically haven't tested on this commit. And that may or may not be a problem depending on what your workflow is, but I just really want to point that out because it's super important. Okay, so let's go ahead and use this script. Have some fun here. So you'll notice here, just as a reminder, this is the root commit, 1, 2, 3, 4, 5 commits on the master branch. Let's go ahead and we'll make a fake feature branch, which we'll call feature X at this state. And you'll see that, remember, branches are just moving tags, so we see feature X here. And we are going to create, let's say, 4 commits here. And so now, if we look at our graph view, we'll see that feature X is ahead of master by 4 commits. Makes complete sense, right? Let's check out back to the master branch, and we're going to create some commits there as well. Let's say we create 3 new commits on the master branch. So now if we look at our history, we see a divergence, which is what we expect. We branched off here. Feature X went one direction. The master branch went another direction. So the feature X branch is an emulation of some feature that you're implementing. So let's go check back out to that and do what is very common in Git workflows, which is occasionally you're still working on your work in feature X branch. Something's come into the master branch and you need to absorb those changes. So what do? You typically git merge with master branch. Now in this case I got a conflict because the file that it creates, the script just creates a a.txt file, and I'm just going to you can see all it does here. I'm just going to pretend like I merged the conflict. It's not real code, so we don't really care about that for this video. And all conflicts fixed, so let's go ahead and commit to finish the merge. And what I wanted to show you here is the merge point. So before we branched off, but we didn't merge back. Now we have a line indicating that we have merged master into our feature X branch. And this is a common view. I mean, if you look at git k, this is basically showing what git k shows. This is basically what you'd see normal day-to-day stuff. Now, what's interesting about the rebase that we're about to perform is we're about to replay the work on the feature X branch, which, remember, it's these stars, so it's these commits and this commit on top of the master branch. And we want to make sure that we are on the feature branch, which we are. And let's go ahead and do it. Git rebase master. So what we're saying here, just to be clear, is we are on the feature X branch. We're going to say, hey, take the commits on our feature X branch that aren't in the master branch and replay them onto the tip of the master branch. So just to be clear here, I want to go over exactly what happened. So we're on the feature X branch. When we tell it Git that we want to rebase our feature X branch on top of the master branch, it's going to rewind our head and replay the work, meaning replay the commits that we've made on our feature X branch that aren't on the master branch on top of the master branch. And you can see here that that was 4 commits, and it applies them individually. And each time it does this, it actually writes a new commit. And you may find that if, in this process, in the rebase process, you have to apply, rebase applies a commit that has a merge conflict, it will stop mid-rebase and have you resolve the conflict, and then you can continue using a command called git rebase continue, and you basically rinse and repeat until the rebase is complete. So what I wanted to show you here is the resulting graph. So remember, before our graph looked like this, where we had the feature X branch had merged with the master branch, and the most recent commit is the merge commit. Now, when we look at the same graph view, we see the feature X branch ahead of master by the commits that were replayed on top of masters. So I don't want to get too much into the details of probing each individual commit here, but I do want to point out a couple interesting things. So remember, before the rebase, we have this E30F commit along the this line of development, and after the rebase, we have that same commit, right? Well, I point out this commit because this is the branch point between the feature X, the divergence point of feature X and master. And so feature X, before our rebase, had 9E90 as the first divergent commit from master. But you'll notice after the rebase, 9E90 doesn't exist at all. On the continuing line of the master branch is the 119 commit, which we do see here, and that is the parent of the A91 commit, which we see here, which is the parent of the A796 commit, which we see here, which is aligned with master. The master branch has not changed at all in this operation. It shows differently on the graph just because it needs to align the commits in a way where you can see the branch, but the master branch has not changed, A79. So what has changed, though, are these commits that were on the feature X branch. So 99 through DA4 were rewritten and do not exist here, and they were rewritten as these 4 commits. So placed on top of the master branch, just like we expected. 2 other quick things I want to mention about this rebase. One is that you'll notice that there are no merge commits. So the rebase basically removed the merge commit that we had before the rebase as part of that process. So that's true whether or not you had a merge conflict in applying the rebase or not. And what this means from a history perspective is that now there's really no record of how the merge was done between the feature X branch and the master branch, and that might be okay. And even if there's a merge conflict, that might be okay. I mean, it depends on what your workflow is and your testing mechanism, and if it's permissive of that type of limitation, then it's not a big deal. And as you'll notice, as a result, you have a linear history, which a lot of people like because it's not very confusing, it's easy to bisect, etc., etc. So another thing that's great about the linear history is that, as you may know from a previous video, it's now possible to squash the 4 commits on the feature X branch into a single commit if it makes sense to do so. So I just wanted to point that out because this type of rebase for advanced Git users can really be the first step for packaging your work for distribution to others. The first step is rebase your content on top of the integration of the master branch, whatever branch you use, and then the second step is squash the commits that you don't need and then push it out to a centralized area or have someone pull from you, etc., etc. So I think I'm actually going to stop the video here. There's so much you can do with a rebase. I want to do a dedicated video on what's called a Rebase Workflow. A lot of teams actually use Git, and they can use Git without even using git merge ever by using the git rebase workflow, and there's pros and cons to doing it both ways. But I just wanted to show you this as the actual real life example of what happens when you do a rebase. And it's not a bad idea to, if you do what we did here, you develop on a feature branch, occasionally you merge with master to get new changes. If it suits your workflow, feel free to rebase with master instead of merging with master, and that'll reapply your commits on top of it, and it's sort of as if they were made on the latest state of the master branch. So give it a shot. If you are concerned that you're a Git newbie and you don't want to mess with rebase because you're rewriting history, I hear you. But the only way you're going to get comfortable is by experimenting, and the best thing you can do is, if you're scared, before you do anything, just simply do something like this. So you can create a backup branch, and feel free to mess with your feature branch by rebasing, squashing commits, what have you. So don't be afraid to try rebase. You can always get back to the state you were at, even if you don't make up a backup branch by looking at the git ref log. And I believe I have another video on that. So anyway, that was the lengthy way of wrapping this up. So just to put a summary on it, syntax for git rebase is, well, let me be thorough here. Okay, so you want to make sure you're on your feature branch, or whichever branch you sort of envision as the work you want to replay onto something. I call the target branch, that's sort of the destination, right? In our case, that was the master branch. So you want to check out to what you want to replay, that branch, and then git rebase with the destination, what you want to replay it onto. So I hope that was helpful. We'll have some more git rebase videos in the future. My name's Dan, and I'll see you next time.